Hello, welcome to my channel. I am Indranil. Welcome to my new video. So today we will do a fine-tuning LLM model using a model we will be taking from Hugging Face, and we will be doing in Google Colab, because for this you will need a GPU. So if your computer has GPU, so you do not need to use Google Colab. But I am doing this in Google Colab because my laptop does not have GPU, and probably many of you do not have this. So before this, so for this, let me briefly introduce that what is a fine tuning. So fine tuning means swad anusar. What does this mean? This means that when you prepare your LLM model for a specific task, then you expect your LLM models to give output in a specific way. For example, when you cook, your each item should have specific taste. For example, a dessert should not be spicy; it should be sweet. Also, when it is a chicken curry or mutton curry, it should be spicy. Just the same way, your LLM model, based on what kinds of work it is doing, so you expect a specific kind of output or result. So let's suppose you are building a simple calculator using AI, or a finance helper for your clients. So for these cases, you want your LLM models should act in such a way. It should not be a creative one. It should not be a good at writing. It should be good at mathematics. Okay, so for this, your model needs to be fine tuned for a specific task. Again, another example could be if you want to create good human-like images for YouTube thumbnails. For this, you give your input image and you expect the image that contains in the thumbnail, it should look like you. It should not look like another one. And also, if you watch my previous videos, I have explained it that LLMs work in a probabilistic way. It gets some tokens as inputs and predict the output tokens. In the same way, for images also, it gets some tokens and it predicts the output tokens. So while predicting these output tokens, it can predict wrong. So if you fine tune your model for specifically for your image, it can give quick and correct output. So these are the motivations to fine tune a model. So with the motivation we have, we can now start. Before this, I am showing you, I am in the Google Colab platform. You can just rename the file here, fine tuning for YT, let's suppose. And then when you are here, you need to connect with a GPU. How can you do this? You will go here in this option, and then you will change runtime type, then T4 GPU, save, and then again connect. So it will be taking bit time to connect to GPU. Also, you need Hugging Face for your model, because you need a LLM model to tune. There is a platform, it is called Hugging Face. I will be going here. So in this website, you will get a lot of free models, and these models you can run on your local machine. So you do not need to have big LLM models. How can you? So there are a lot of models here you can watch based on like what kinds of work you want to do, or text to text, image text to text, or visual question answering. So for this you need different many kinds of models you can work on for your project. And you will need a token for our project. So from where you will get this? You will go, this is free completely, so you can go here. So in profile, and not profile, it should be somewhere in the settings, most probably. Yes, in the settings it will be in the access tokens. And in the access tokens, I have one as named as test. So in the access tokens, you will be able to create another new token, and it is free, you can use it. So this token you can use this, or we have used this for a model, specific model, we have to do this. Okay, so we are now pretty ready with our Google Colab platform and the Hugging Face token. If you want to create a new token, you will just simply click here, create new token, and get a new token. Now, once we are ready, we are connected to the GPU. So if you want to watch that if your GPU is already there or not, there is a specific code I will be able to show you. Or okay, it is showing connected, so you can pretty sure that it is connected. uh, for our project we need to use a library which is called transformers. Okay, so what these transformers have, this transformer library is a NLP library. It has tokenizer and the LLM models inside it. We will use this tokenizer and LLM model functions from this transformer library for our specific purpose. So let's just get install it. So you have to install it using pip install. So we have to wait for a little bit, and yeah, it is now installed. So I'm just commenting it out. It looks bad. Yeah, now it is good. So the transformers have been installed for our purpose, and now what we will do, we need to use the token. We need to use the Hugging Face token. You can watch my token as of now, but I will be deactivating this after this class. So anyway, it is free. So operating system import and then the token, and we need to put this in the environment variable. So in the environment it is loaded. Now we can use the Hugging Face platform and their models from now on. Now we have to also set our device. For setting our device, what we need to do? For setting our device, we need to connect with the GPU and use the torch. So import torch, and then we have to do device equals to torch dot device and then I have AI already here, so that's why it is showing me some response. Okay, so if this is CUDA is available, if torch dot CUDA is available, else CPU. So this means that your device is now set to the GPU we have connected, or else if it does not, the GPU is not there, then it will use the CPU, normal CPU. Now okay, now we have to import the uh, tokenizer from the transformers. How to import? So from transformers import, we have to import auto tokenizer. Let's not import the model now, we will use it later. So we have imported the auto tokenizer. What the auto tokenizer does, let's understand this a little bit. We need to feed the tokens to the models. Whatever we are asking, let's say if you are asking in the chat GPT, hey there, uh, what is LLMs? So that means these words are transformed into tokens, and these tokens are then fed into the LLMs. Based on the tokens, LLMs give some output, and these outputs are then detokenized, and then you get to see the response from the LLMs. This auto tokenizer does the exactly same thing. It tokenizes your messages. Let's suppose we have to model, which model we are use. So we are going to use Google Gemma uh, 3. We will be using 1 billion parameter. 1 billion parameter does mean, it just means that how many parameters you can control simultaneously. So we are using 1 billion, so you can use more if you have much power of GPU or pro version of Google Colab. I will be using the minimalistic one, this 1 billion, that will pretty much serve our purpose. So this is model name. Then our tokenizer equals to auto tokenizer, and then from pre-trained model name. So now we have our tokenizer. We need to run this one. Yes, it's running. Let's wait a little bit. Yes, I think it's now done. Okay, let's wait for a little bit. Oh yeah, it should the config.json file. Yes, now we have the uh, We have the tokenizer function. We also need a LLM model because we need to chat or we need to fine tune the model. So for this purpose, we also need the transformers. We need to call this one, this import causal LM. This library actually will fetch the model, this Google Gemma 3 1 billion parameter. So this model will be fetched by this auto model for causal LM by from the transformers library and from the model. So let's run this also. Let's wait for a little bit. What it is doing, it is basically fetching all the model and its parameters and run in the on the GPU. So you from now on you will be able to run the LLM models on your local machine using this Google Colab. Let's just fetch, wait a little bit to complete this. Yes, by the way, don't forget to share what projects you are building now. I read every comments. Just put a comment there. We'll be get in touch. And if you want to work with me also, you can email me, or I am ready to collaborate with you. So just put a comment there. Okay, so we have tokenizer and model already in our setup. Let's see if the model works or not. So how we can see that, how we can see, okay, one more thing, that we have to attach this model to the device. The device means this device what we have created using the GPU function. So we have to attach this model to the device. So how we can done this? Okay, so to do this, what we have to do, yeah, so model equals to auto, yeah, this one will do the, then from pre-train model name, no, we don't need this, use auth token, this model name, then torch type, this torch b float, so this one, and then to device. Yeah, now we are pretty much ready. So we now, yeah, we could have done this in this also, but okay, fine. Again, we have to do this, config the model. Sorry for my mistake. We have to attach this to the device. Okay, now we have this tokenizer and model ready. Let's see if if our model and tokenizer works perfectly well. For this, let's write a input prompt. Input prompt equals to what is the best channel to learn Gen AI. Okay, so this is the input prompt. Then we have to tokenize this. I tokens equals to tokenizer. Yes, tokenizer. Then we have to give the input prompt and this return tensor pt. So let's see how the I tokens looks like. Yes, this I token, this tensor means this is a matrix. So these are the tokens for this. What is the best channel to learn Gen AI? So this is the tensor. So if we want to get only the tokens, we need to call this I tokens. Sorry, I tokens. Then we need to call this as input IDs. Yes, yes. So we get only this. We can give these tokens to the model and we will see how the output looks. So output model equals to model dot generate, and this maximum tokens, let's just do this as 25, and then I tokens, let's see. Okay, we have got an error here. I tokens. Okay. Okay, we have to detokenize it. Output tokens equals to this. We have to use this tokenizer again to output. Sorry, we have to use this batch decode method and then output model. Okay, let's see. Um, oh yes, sorry, there is a mistake here. This I took, I have not stored it anywhere, so we have to give the tokens. That's why I was getting this here. Let's see this. Okay. Okay. Probably this is not working. I can understand why, but now these I tokens, too many indices. Why it is working like this? Okay. Now we have to erase this one. I tokens. Sorry, there was a mistake from my side that I forgot to add these tokens to this device we have created. Now they will be working pretty fine. So whatever, so because there was two devices involved in it, therefore I was getting this error. That's why I attached the tokens that we have generated in the output model as well. Sorry, in this device as well. So now probably they will be working fine. Let's see. Output model that generate. Yes, now we are getting what is the best channel to learn Gen AI. There are many excellent channels on YouTube, but here is a breakdown, the best ones categorized by their strengths. So let you can see now you have successfully run a LLM model on your local machine based on using the Google Colab's GPU and the Hugging Face models. But we need to get the outputs right according to our way. We want that it should show that the best there are we should show we, sorry, we want to get the best channel to learn Gen AI is Indranil Suwarji. Okay, so we want that our output should look like this. The best channel to learn Gen AI is Indranil's ORG. Sorry, this was a mistake in writing Gen AI. So you are basically telling your LLM that whenever someone is asking that what is the best channel to learn Gen AI, you should be promoting yourself. The best channel to learn Gen AI is Indranil Suwarji. For this, you need to train this model to give this specific output when it gets this exact input. Let's see how we can do this. For this, we need to prepare our dataset. What will be the dataset here? I will show. Before that, let's just create some input conversation. How it will be looking like input conversation. It should be like this. Oh, sorry, I forgot to bring the equal sign. Yes. So it should be input conversation. So it is role. So I am just showing it here. Yeah, so role the system is you are an helpful assistant who resolves users query, and then the user what it can ask that oh sorry okay, not the user, we are not putting the user now, we will be assistant, and the assistant so assistant is asking the question. Okay, assistant, it will be showing. Okay, we have to put the user here also, role user. So what is the best channel to learn Gen AI? Then the assistant should show the best channel to learn Gen AI is. Now we have to stop here. So we are setting up our input conversation. So when a user asks what is the best channel to learn Gen AI, and then the assistant should be here. The best channel to learn Gen AI is. So after this, you want that it should give the Indronil's org. How it would go? Okay, so it is the input conversation. So we have written the input conversation. After this input conversation, we need to tokenize this input conversation first. So let's do this. So we have this input d tokens now. Now this we are output. We are creating that whatever is the output level. This means that what should be the after this best channel to learn Gen AI is. So whatever should be after this. So we want this as Indronil's channel. So we want this to Indronil channel. So now the full conversation, how does this look like? On full conversation is equals to it should be input d tokens plus output label plus EOS. There is a tokenizer dot end of string token. So now this is the full conversation, and let's see how the full conversation looks like. Yes, the full conversation looks like this: that you are a helpful AI assistant who resolves users query. What is the best channel to learn Gen AI? Then it will be shown that the best channel to learn Gen AI is Indronil's channel. Now we have to we have to tokenize this input conversation, full conversation, at input tokenized equals to tokenizer this full conversation, and then I have done this to also, so to device. So this full conversation is now input tokenized. How that does this look? So this looks like a tensor. Okay, fine. So we have input tokenized the full conversation. Now we need to look at something. Let's go to our eraser. So whatever we are checking that whatever we are checking that what is the content now, sorry. So what is the best channel to learn Gen AI? So now whatever output we are expecting, that the best, sorry, oh, the best channel to learn Gen AI is Indronil's channel. So you can see we are actually shifting this process. What is shifting this process means? So this, if this is the input of the user, then we are just taking this part and adding after this Indronil's channel. Basically, if in terms of token you want to understand, let's suppose you have your initial tokens. So 1, 2, 5, 3, 4, 3, 4, 5. So your expected output is basically 2, 3, 4, 5 and 10. So what this 10 is? This 10 means this Indronil's channel, and this 2, 3, 4, 5 means the best channel to learn Gen AI, and 1 is what is. So basically you are shifting this process. Basically you are shifting the tokens. Now you are doing the same thing here. We have to do the same thing here. We have to set the input IDs and the target IDs. So what will be the input IDs and target IDs from the full conversation? I am writing out this here. So the input IDs is this input tokenized, and out of there the last one we are excluding. This last ones we are excluding because these are the results, this Indronil's channel. Apart from this, these tokens are the input IDs. This means this is what is the best channel to learn GenAI. And what are the target IDs? These target IDs are everything, including the last ones. The best channel to learn GenAI is Indranil's channel. So these are the input IDs and the target IDs. Now we need to define a loss function and calculate and give input to the LLM models and get the output and check how much it is close to the target IDs. So first put this input IDs and target IDs, and then I will just be copy pasting from we have written and understood what the target IDs and input and target IDs are and why those have been taken such a way. There was a mistake from my side earlier, so I have corrected them. I have not a big mistake, but there was I forgot to attach the model to the device, so as a result, I was getting this error. So now we are just putting the loss function inside it. So this function will calculate the loss every time, and we will use this Adam MW for this calculating the loss function. I'm just copy pasting it the function. You can usually copy paste it or use it, and every step we will see how this loss is decreasing or not. Let's see. Okay, now you can see when it is started 0.44, then it increased the loss 0.82, then it start decreasing again and again, then it was fluctuating, but now we are pretty much what we are started 0.44 where it's the loss 44%. Now we are at 15% loss. So let's see if now what our code will be giving as this output now. So what if if we want to see the output now, we need to again give the input prompt that user, which is the best place to learn Gen AI, and then we have to tokenize this and apply chat template and fit the input prompts the same way, and then the output we will get giving this input tokens and max new tokens. So let's see how this what this gives us. Yes, now it is giving this as Indranil's channel. So we started with different thing, but now we have trained our model to get that what is the best place to learn Gen AI is Indranil's channel. So this way you can use fine tuning our model. The important step is to create this full conversation, and then after this full conversation you need to use this how this tokenizer works and the full conversation and calculate the loss function each time. So depending on your dataset, it might take a lot of time or small time based on the data sets you have. So you can use this technique to build any application, or if you want a specific task for a model. Hope you enjoyed this video, and if you do so, please like and subscribe, and don't forget to share what you are building. Thank you. Bye.